Okay, so let's take a look. We're using synthetic division. So when we do that, whatever this factor is, we use the zero from it. So since if I had like x plus 2 equals 0, then it's 0 is negative 2. The same as like when we were factoring stuff, we'd have x plus 3, x minus 5, and then the zeros are their opposites. So that's what we're doing with this piece. So let me go ahead and clear all that. Do that and clear. So we do a negative 2 on the outside, and then we set up all our coefficients on the inside. We have x cubed, and it's a 1x cubed, so I'm just going to put the 1 there for the x cubed. We have a 1x squared. We do not have an x term, so I'm going to put a 0 there as a placeholder, and then we have a 4. So x cubed, x squared, linear term x, and then the constant. And then kind of once you get the pattern to this, it's the same thing over and over. So the first thing we do is we bring down whatever's in this first spot, and we go negative 2 times that number, which would be negative 2, and it goes right here. And then we're adding, so negative 1 plus negative 2, or you can think of it as 1 minus 2, because it's the same thing, would make a negative 1. And then we do a multiply again, and we just repeat that till we're out of stuff. So negative 2 times negative 1 would be positive 2, and then 0 plus 2 makes 2, and then negative 2 times 2 would make negative 4, and 4 plus negative 4, or just 4 minus 4, would make remainder 0 on that one. And since this was x cubed plus x squared plus 0x plus 4, this is always going to be 1 degree less because we're going x into x cubed, so that'd be x squared. So this is 1x squared minus 1x plus 2. And that's your basic on how you do a synthetic. Let me clear that one. I'll make up one more here. Let's say I had x minus 3 into x cubed minus 4x squared plus x minus 5, just to make something up. So I could do this long division way, but synthetic is so much easier once you get the hang of it, so I'm going to do it that way. Here we would just say the 0 on this, since it's an x minus 3, would be a positive 3. And then we have a 1 on the x cubed, a minus 4 on the x squared, a 1 on that x, and that's what we're having the placeholder for on this one. And then the constant is minus 5. And we just see what it does. So we bring down our 1, and then we go 3 times 1 makes 3, and negative 4 plus 3 makes negative 1. 3 times negative 1 makes negative 3. 1 plus a negative 3 makes negative 2. And 3 times negative 2 makes negative 6. And negative 5 plus negative 6 makes negative 11. So again, since I was going x into x cubed, this would have to be an x squared. It's always 1 degree less. So this would be 1x squared minus x minus 2, and then minus 11 over x minus 3. So that's your basic plan. And again, kind of once you get the hang of that, they're all the same. Let me do one more. Let's say we had x minus 2 into x to the 4th plus 3x squared minus 5. So I'll do one with a few more missing terms. So this one 0 would be 2. And then this is x to the 4th, so that's a 1x to the 4th. I don't have a cube term, so I'm going to put a 0 in there for the placeholder. My squared term is 3. I don't have a linear term, so I need another placeholder there, because this is like x to the 4th plus 0x cubed plus 3x squared plus 0x, and then minus 5. And we bring down our 1 and just kind of see where it goes. So 2 times 1 is 2. 0 plus 2 makes 2. 2 times 2 makes 4. And 3 plus 4 makes 7. 2 times 7 is 14. 0 plus 14 is 14. And 2 times 14 is 28. And so I think that would leave me 23. So final on this. This time notice I'm going x into x to the fourth, so 1 degree less, this would be x cubed plus 2x squared plus 7x plus 14 plus 23 over x minus 2. So like I said, you can do these either way, but if, well, not quite. You can do these using synthetic division as long as that number right there is a 1. If this is something else, then this doesn't work. But when you have the choice to do synthetic, and it's a lot less math, it's a little bit witchcrafty when you're first learning it, but once you get the hang of it, it's pretty quick and a lot less error prone than doing this way. Hopefully that helps.